Hey ladies and gents, I'm not here today. I apologize. I think I warned you last week that I wasn't going to be. So there's a couple things I'm going to have you do today. First off is, if you haven't already, grab one of these pink sheets and give it a go. We're going to go over this. We're going to go over, I think, 2 problems from the homework, and then I'm going to get you started on what your class assignment is for today. Okay, but I want to make sure to review a little bit of the rational zero theorem first with this sheet and by going over a couple of last night's homework problems. So let's start with this sit and begin. If you haven't done it yet, pause the video and do it, and then come back to it. Doug and Micah are listing all of their possible rational zeros, okay, for this polynomial. Okay, rational zeros lets you know rational zero theorem, okay, rational zero theorem. Are either of them correct? Explain your reasoning. So to figure out how many rational zeros, not just how many, but what are they possibly going to be, we need to look at our factors of our constant. So we're looking at the factors of 16 over the factors of our leading coefficient, which in this case is 4. So we think of what things multiply to be 16. So we have 1, 16, 2 and 8, and 4 times 4. And then factors of 4 are pretty easy. 1 times 4 and 2 times 2. Again, these could be both positive and negative versions. So I'm just going to look at all of the combinations of the numerators and denominators and see what they can make. So 1 over 1 is going to be 1. Again, plus or minus for all of these. 1 over 4 is 1/4. And 1 over 2 would be 1/2. So 1/2, 1/4, and 1. 1/2, 1/4, and 1. So far, so good on both. Now let's look at 16. So 16 over 1 is 16. 16 over 4 would be 4. And 16 over 2 is going to be 8. So 16, 8, and 4. 16, 8, and 4. So far, so good. 2 over 1 is 2. It's not included. And it happens to be here and here. 2 over 4 is 1/2. We already have that listed. And 2 over 2 is 1. So I don't need to add anything but this 2. 8 over 1 is 8, right there. 8 over 4 is 2, and 8 over 2 is 4. All of those are included. Next, we have 4 over 1, 4, right there. 4 over 4, which is 1, and 4 over 2, which is 2. So these are our lists. Micah included an extra factor that we didn't need. So, who is correct? Doug is right. Good job, Doug. Okay? You found all of the possible rational zeros by looking at your factors of your constant over your factors of your denominator. Okay? So this was kind of our new learning last class that we had to use that to build on it for your homework. Now, depending on your class, I told you kind of a mishmash of problems. I don't think I was very consistent whether you had to do number 3 or not. But I know either way I said odds. So it was either odds 1 through 7 or 9, or I said don't do 3. I don't remember which class I said what to. I apologize. I should have written it down. And I should have given you both the same assignment. So, number 1, hopefully we're good with this one. We do our factors of 24 over 1. So they're all constant. So these are just factors of 24. Number 3 was pretty tricky. You probably need to look up how to find the volume of a triangular pyramid. Okay? This was a hard problem. I'd rather spend time talking to you about it in class if you would like to. Tomorrow, I don't mind doing it. All right? But I don't want to do it in this video. It'll take a lot longer than we want it to. All right? But our answers were 5, 9, and 28. Then find all of the rational zeros for each function. So not all of the possible rational zeros. That includes everything. This one is actually check them and see which ones are going to work. Now in number 5, there's only 2 that are going to work. They're both negative. So to start off number 5, because I'm really only going to go over 7 and 9 in this video, what you should do, I know you're thinking rational zero theorem, so you do that, you get all of your combinations. But you should also look at Descartes' rule of signs, because you might not have to check any of the positives or any of the negatives or whatever. But you need to go through that list of rational numbers that you get from this. Okay? And you need to guess and check. Okay? You only have a short list, so you got to guess and check until you find the correct combination of numbers. And those should have been -3 and -1. Next, 7 and 9. These you have to find all of the zeros for each function. So in the past, if you checked like a whole number and it worked, you were like, great, and it became a 3rd power to a 2nd power, and it was nice. Well, here we're dealing with a 3rd power, so all you have to do is find 1, and then you can use a different strategy. But here we're dealing with a 4th power. So you probably have to find 2 zeros first, and hopefully there's 2 rational zeros. simplify it to a quadratic, and then go through solving it, okay? So if you got both of these right, 7 being these 2 solutions and 9 being these 4 solutions, okay, great. Skip way forward to when I talk about today's assignment. If not, I'm going to go over 7 and 9, just skip forward or backward or whatever to whatever you need, okay? I'm going to start by looking at 7. We have 8x to the third plus 14x squared plus 11x plus 3. I should start off by either doing the rational zero theorem or Descartes' rule of signs. I need to use both. It doesn't matter which one I start with, okay? So I'm going to start with the rule of signs. All of these are positive. So my positive zeros, well, my positive zeros are going to, there's none of them. I don't even need to write positive 0, 0, whatever. There's going to be no, because there's no sign changes, okay? If I plug in a negative x, so f of negative x, Descartes' rule of signs, odd power means sign changes. It's going to be a negative 8. It's an even power. This sign's going to stay the same. This is an odd power. That sign's going to change. And this one's a constant, so it stays the same. So 1, 2, 3. Wait. 1, 2, 3. 3 changes, so I could have 3 or 1 negative rational zeros. So when I make my list of possible rational zeros using the rational zero theorem, I'm never going to try a positive. It is a waste of time. Instead, I'm going to be trying 3 or 1 negative values, okay? So I'm going to do that. Let's see here. Let's do our rational zero theorem. So I'm going to look here and here. My factors of 3 are 3 and 1. My factors of 8 are 1, 8, 4, and 2. So I could have 3. I could have 3/8. I could have 3/4. I could have 3 halves. I could have 1. I could have 1/8, 1/4, or 1 half. And I cannot have the plus or minuses of these. I don't care about the positives. Any of these would have to be negative. So your infinite list now that you have to do becomes a list of only 1, 2, 3, 4, 5, 6, 7, 8 possibilities. Now I got negative 1/2 last, which means I probably would start with my whole numbers, or excuse me, my integers, and then work all the way down to those rational negatives. Okay, probably starting with easier and harder ones. I know negative 1/2 is going to be the answer, so I'm just going to show you how that would work. I'm going to do negative 1/2 here. And my coefficients with fillers across the top, 3, 2, 1, and none, no fillers needed. So I'm going to have 8, 14, 11, and 3. I want my remainder to be 0 if it's a factor. So 8, I'm going to drop my 8. Negative 1/2 times 8, half of 8 is 4, make it negative, negative 4. And 14 is 10. Half of 10 is 5, make it negative, negative 5. So negative 5 and 11 is going to be 6. Half of 6 is 3. Make it negative. Negative 3 and positive 3 is 0. Yay, I found a factor. That means I'm left with, if this was a third power, 8x squared plus 10x plus 6. Okay? I'm going to quickly check. Can I factor this? What multiplies to be 48 and adds to be 10? So I initially thought 12 and 4, but that's going to be 8. 6 and 8 obviously don't add to be 10. So that's not going to work. There's nothing. I have to use quadratic formula here. So I'm going to do negative b plus or minus the square root of b squared minus 4 times a times c. So 4 times 48. Oh my God. 32, 16, 17, 18, 19, 192. All over 2a, which is 16. 100 minus 192 is negative 92. Okay, so at this point, I'm going to factor tree my 92 over here. I know I'm going to pull out an I because it's a negative. 92 can be broken into, I should check my perfect square. So I'm going to grab a calculator, actually. My lowest perfect square is 4, so I'm going to do 92 divided by 4, and it works out 23. And 23, I'm pretty sure that's all that I can get from that. So this can be rewritten as negative 10 plus or minus. Since these are both roots, and this equals 2, I could have 2i root 23 all over 16. Now, each of these numbers is divisible by 2, so I'm going to have negative 5 plus or minus I root 23 all over this divided by 2 is 8. So there are my two solutions. They happen to be imaginary, and I had one rational. Okay. Now, I could have kept checking to see about getting the other two negative rational numbers, but once I'm at a quadratic, I shouldn't do that. That's a waste of my time. Once you're at a second power, either use quadratic formula or factor it if it's factorable. And number 9 is like 7, but a little bit harder because you have a power of 4, okay? So let's take a look. I'm going to do Descartes' rule of signs first. So sign change, sign change, sign change, no sign change. So I'm going to have 3 or 1 positive zeros. I'm going to do f of negative x. So even power, it's going to stay the same. Odd power, it's going to change. Even power, it's going to stay the same. Odd power, it's going to change. And that's going to stay the same. So if I look, the only sign change is here. I am definitely going to have 1 negative, okay? 1 negative 0. So I'm guaranteed a positive, I'm guaranteed a negative. I'm going to use the rational zero theorem to figure out all of my possibilities. So I'm going to look at the factors of 15 over the factors of 4. So my denominator is going to be 1, 4, and 2. My numerator is 1, 5, 3, 15. So all those combinations are going to be 1, 1/4, 1/2, 5, 5, 5/4, 5/2, 3, 3/4, 3/2, and 15, 15/4, 15/2. Okay, again, these are all pluses or minuses. Is this ideal? No, but you have a starting point. Okay, you know what the possibilities are. You're going to kind of guess and check positive and negative values here. Okay, once you hit a positive working one, you could continue. But honestly, once you get one positive, I probably would have popped down and gotten the second negative. Okay? Because once you get the positive, once you get the negative, you're going to be at a second degree polynomial, okay? Which means it's going to work. And you're going to be able to factor it. So again, I'm not going to go through that whole table, but that's how you should start doing this. I'm going to try to save time because I want you to practice more on your own, okay? So this is the guess and check list. It's not great. I get it. Keep in mind, you're going to have 1 negative. Get your 1 negative, find only 1 positive, even though you could have 3, and then factor it. Or in this case, you're not going to be able to factor it. You would have to do the quadratic formula. Okay? All right. Let's talk about, I know that's not all the way to the answers, but again, I want to save time. Okay? Let's talk about what your assignment is for today. So all of you folks, after seeing this video, should go grab this sheet from the sub. Alrighty? It goes over 3 different sections, kind of. The first one, and you're doing only odds, excuse me, is list all possible rational zeros.
Just a reminder that the Girls' State meeting is happening in the library at this point. If you did get notification about that, please come to the library now. Thank you.
It's after school right now, just so you know. Okay, anyways. All possible rational zeros right here, okay? So those 3, list all of them out, then you're done. Next section, find all the rational zeros of each function. So if it's a rational number and you don't have to do quadratic formula, you need to do it. So this is an example of one. All right, here's x to the 3rd power, and then a second, and then a first, and then 15. The answer is going to be 3. This is right from the key. All right, if we take this and we do our rule of signs, if we take this and we do the rational zero thing, you're going to get a whole list of numbers. Once you get it to a quadratic, so once you find 3 works, okay, then it's a quadratic. If you can't factor it, you only write those rational numbers. If it's going to have an I or if it's going to have a root, that's a hot mess. If you have to use the quadratic formula, stop and only write the answers that you have. But if you can factor it when you're at a quadratic, okay, then you should factor it, and that's where you're going to get situations where you have more than just that 1 rational number or 2. Okay, you are not putting imaginary solutions here. Okay, you're not going that far. You are not using quadratic formula. Stop before you would. However, this next section, 21 and 23 only, because you're only doing odds, you need to find all of the zeros. So you're going to go through Descartes' rule of signs, check for positives and negatives, think about your imaginaries there too, make your table if you want, okay? Then do your rational zero theorem. What numbers could possibly work here? We're dealing with something to the fourth power. Ugh, we're going to have to find two that work to get it down to a quadratic. Once you find two that work and you can get it down to a quadratic, do the quadratic formula if you have to. And in this instance, you're going to have to because it's not nice rational numbers. Okay? Again, this key is up. I want you to know if you're doing it correctly or incorrectly. I do want you to attempt 25 at the bottom, okay? Word problems are a thing, and they're actually a huge part of this specific strategy, okay? And about solving polynomials. That's when you would actually need to do it, okay? So please take all that into consideration. You're doing this whole sheet, odds only, okay? Write down that left-hand side. Give it a go, check your answers, alrighty? We're going to be reviewing for a test tomorrow. I will be here, and I will build in time to go over these problems as needed. All right, make sure you get one of these sheets from the sub. Thank you very much, folks. I will catch you later.